All right, so we have a bullet being fired from a gun. We can assume it starts from rest. So I'm going to show the bullet. The bullet's just going to be a ball because I'm a horrible artist. V initial is 0. Okay, the trigger gets pulled and the bullet accelerates down the barrel of the gun, and it comes out over here with a velocity of 300 meter per second. So that's V final. V final is 300 meter per second. What else do we have? The length of the barrel, which is that's our displacement, is 0.5 meters. That's from where the bullet starts to where the bullet comes out. Displacement of 0.5. And the mass of the bullet, make sure you put that in kilograms. Mass of the bullet is 0.002 kg. Now, question A, super easy. What's the kinetic energy of the bullet? All you got to do is go like this. Kinetic energy is 1/2 mv squared. So you plug in 1/2 0.002 kilograms. Velocity is 300. You square that. So this comes out as 90 joules. Okay? So the bullet gains, how much kinetic energy? How much kinetic energy does the bullet start with? 0. How much does it end with? 90. So the kinetic final is 90 joules. So now let's go to part B. So for part B, find the average force. Find the force exerted by the expanding gases. What the heck? I mean, I guess that's how a gun works. Gases expand, pushes the bullet down the barrel. Basically, they want us to find the force of the gun on the bullet. What is the force that the gun exerts on the bullet as it moves down the barrel? Now look, what's the only force acting on the bullet as the bullet goes down the barrel? The only force doing work is what? The force of the gun. We'll just call it force of the gun. Oh, and look, is there also mg? Yeah, mg down. Is the bullet resting on the floor of the barrel? Yeah, so there's a normal force, but are those forces doing work? Mg and the normal force are not doing work. The only force that does work is the force of the gun. Now what about friction? Could friction be in there? Yeah, but the rule is if the problem doesn't mention it, we assume no friction. If they don't mention anything about friction, there's no possible way to factor it in. Does that make sense? So the only force doing work is the force of the gun. So let's solve it using this equation here. Work net equals kinetic final minus kinetic initial. What is kinetic initial before the bullet's fired? 0, because before the bullet's fired, it's just sitting there. So what we have for part B is the net work done is going to equal the final kinetic energy. Okay? Now what is the net work? What's the only force doing work? The gun. So work net is basically the work of the gun on the bullet. And that's going to equal kinetic final, which we know. Kinetic final is 90. Now guys, what is the basic work equation? The basic work equation is what? Force times displacement. So now come up here. So this work of gun is going to become force of gun times the displacement. That's the work equation. Equals kinetic final. So now we can solve for the force of the gun. The force of the gun is going to be equal to kinetic final divided by the displacement. So that's 90 joules over 0.5 meters, which gives 180 newtons. Yo.
If you could keep, like I did it chapter 4 way, is that fine?
Oh yeah, to do this chapter 4 style, what you would first do is use a kinematic.
Yeah, find acceleration.
Find acceleration with a kinematic, and then what you would do is you would go, okay, force of gun, what's the only force in the x direction? The force of the gun, so what does that equal to? MA. So you plug your A in, you got the mass of the bullet, you'll get the same answer.
Yeah.
That's chapter 4 style, yeah. But I solved this chapter 5 style. So the first, I don't know, the first 10 problems or so, you're going to be using this equation. The net work on an object is always equal to change of kinetic. Okay?